Hello guys, in the last video we did unsigned number subtraction. This time we'll do signed number subtraction. Okay, so what do we mean by signed numbers? Okay, let me remove these comments so I could explain it to you. I explained this in the last video as well. 4 minus 2 equal to 2, right? This is unsigned number because we don't get any sign here. Okay, this is just 2. Okay, but if we switch them and we do 2 minus 4, what we get? Minus 2. Now this is a signed number. Okay, so we have to deal with it differently in our program. Okay, so now just let's write the code here. So first move x and 2, move bx. Okay, you should be familiar with these commands by now. Okay, and now finally sub x and bx, and this is actually saying 2 minus 4, which will be minus 2. Okay, so first let me execute this and let me tell you what will be the issue if you execute it directly like our previous program. Okay, so you emulate it, single step, our result will be stored in x. Okay, and you see we get this string number here. If you double click on this, you'll see you get decimal or conversion of the same number. Okay, so you see this is 255 in unsigned. We don't need unsigned because we did what? We did signed number subtraction. Okay, so this is minus 1. This means this is negative number, and this 2 means minus 2 means that our result was 2. Okay, this minus 1 means it was a negative number, and this 2. Okay, so we could check our values from here, but on MTS-86C this won't be easy. Okay, so we won't be able to convert it that easily. We have to use some conversion methods or other. Okay, so simply what we do is we take 2's complement. Okay, you should have remembered what 2's complement does. It switch the sign. Okay, so it will switch the sign and convert this number into 2. Okay, so now you see the problem. Like, to address it, we do not x. So this is what? This is 1's complement. And if you remember how to take 2's complement, we first take 1's complement. This actually flips the bit. Okay, so if it was 101, after this it becomes 010. Okay, so it flips the bit. Okay, and then after that we add 1 to it for 2's complement. Okay, and what this does is it add 1. Okay, so after 010 it will become 011. Okay, so this will be our 2's complement. Okay, so let's just execute our program. Okay, this is our 2's complement. Okay, and in the end don't forget to do halt here. Okay, otherwise it will be really hard, HLT. Okay, to stop your program. Emulate. Okay, single step. Okay, you see you get 2 and 4 here, and another one. Okay, you see we get the same value here. Okay, and after, now you see that we do 1's complement. After 1's complement we get 1. Okay, and if we do 2 complement, you see we get the 2, which is our result. Okay, but what we wanted 2 as a result. Okay, so it won't show any sign because this is basically converting it into an unsigned number, but we get the result as 2. Okay, if you do different values, 4 and 8. Okay, so single step. So now we were there. Okay, 08. Okay, we moved 2 values into the register. Now we subtract them. Okay, we get this result, which is actually minus 4, but we convert it into using 2's complement into the unsigned number 4. Okay, so this is our result. Okay, so now we have successfully written our program. Let's just execute it, simulate it into our MTS-86C. Okay, so you guys should remember the 3 steps now. Examine register x. Okay, we put 04, then 08, then we go back and write our program into from the 100 location. Okay, I'm going fast because I think you guys should have known already these basic steps. Okay, so now we start writing our program from here all the way up to here. Okay, in the same order. Okay, so first is B8. Okay, it is already there. 04, 00, BB. Okay, and now this is 08 actually. So these 08 and 00. Okay, it's already there. These values are the previous values that I wrote previously. Okay, so these get stored in the memory. Okay, 0 0 and then 2b, okay, then c3 the same, f7, okay, f7, then d0, then 0 5, 0 1, 0 0, and finally f4, okay. Now we execute this program, okay, or third step. Start executing it all the way up to f4, okay. We go back, we examine register, okay, we check our value, and indeed 8 minus 4 equal to 4, okay. Alright guys, this is it for this video. I'll see you next time.